China has built the world's largest radio telescope. Located in the remote mountains of Guizhou Province in southwestern China, this telescope is called FAST. Its main dish has a diameter of 500 meters, covering an area roughly equal to 30 football fields. Instead of constructing such a massive structure on flat ground, China took advantage of a natural bowl-shaped depression in the mountains. However, FAST is remarkable for more than just its size. Portions of its metallic surface can change shape as needed. At the same time, the receiver suspended above the dish by cables can also move according to the position of the target. As a result, the telescope can detect extremely weak radio signals arriving from different parts of space without rotating the entire structure. How did China transform a natural mountain depression into the world's largest radio telescope? That's the story we'll explore in today's episode. The human eye, or even a conventional optical telescope, cannot see everything in the universe. That's because many stars, gas clouds, and stellar remnants emit radio waves that are either very faint or completely invisible in visible light. But those same waves can be detected by a radio telescope. They can even pass through regions hidden behind thick clouds of cosmic dust and still reach Earth. That's why radio telescopes are essential for uncovering the hidden parts of the universe. However, these signals travel across immense distances and are so incredibly weak that they can easily be overwhelmed by Earth's own radio interference. A larger dish collects more radio waves and directs them toward the receiver. As the collecting area increases, so does the likelihood of detecting the universe's faintest radio signals. China realized that making major discoveries in radio astronomy would require more than simply following the work of others. It needed an extremely sensitive observational instrument of its own. The country needed a telescope capable of surveying vast regions of space, while also detecting signals so weak that smaller instruments would easily miss them. To achieve that goal, China built the 500-meter Aperture Spherical Radio Telescope, better known as FAST. FAST's primary scientific mission was to create a map of hydrogen throughout our galaxy. In 1994, Chinese astronomer Nan Rendong began planning the construction of a powerful radio observation system. His inspiration came from the Arecibo telescope, which had also been built inside a natural mountain depression. However, Arecibo's fixed spherical dish could observe only a limited portion of the sky. Nan Rendong's vision was to take the same fundamental concept and make it much larger and far more technologically advanced. He wanted to create a reflector whose shape could be adjusted according to the needs of each observation. But finding a suitable location for a 500-meter diameter dish was far from easy. For nearly a decade, Nan Rendong and his team traveled throughout the mountainous regions of southwestern China in search of the perfect natural depression. Eventually, they selected the Daodang Karst Depression in Pingtang County, Guizhou Province. It was deep, nearly circular, and remarkably well matched to the planned size of the dish. As a result, instead of constructing the entire structure on flat ground, they were able to use the mountain's natural landscape as its foundation. Another major advantage of the site was its limestone terrain. Rainwater drained easily underground, greatly reducing the risk of water collecting inside the enormous dish. At the same time, the surrounding mountains partially blocked unwanted human-made radio waves from distant sources, helping shield the telescope from external radio interference. In other words, Guizhou was not simply an empty hole in the ground. Its shape, natural drainage system, and surrounding mountain barriers made it an ideal location for building FAST. Even after finding the natural depression, transforming it into a radio telescope was anything but simple. After construction began in 2011, the first step was to survey the mountain slopes, remove unstable rock, stabilize the ground, and build a strong support infrastructure around the entire basin. After all, the enormous tension from thousands of steel cables would eventually have to be supported by this very structure. Next, engineers stretched a massive cable network across the entire depression, resembling a giant spider's web. This network not only supports the reflector panels, but also moves up and down as needed during observations, allowing the shape of the dish to change. Connected to this enormous cable network are thousands of actuators, or control devices. These allow the overall shape of the structure to be adjusted with extraordinary precision. The most visible stage of construction was the installation of the reflector panels. Beginning in August 2015, a total of 4,450 triangular panels and 150 specially shaped panels were installed on the cable network in just 11 months. Each panel was built with a lightweight aluminum frame to reduce the overall weight of the massive surface and minimize unnecessary stress on the cable system. At the same time, the towers surrounding the dish and the cable system used to move the receiver above it were also constructed. Finally, on July 3, 2016, the last reflector panel was installed. After completing the remaining equipment and systems, the construction of FAST was officially completed on September 25, 2016. The radio signals arriving from the universe are so incredibly weak that even the emissions from a nearby cell tower or an electrical device can easily overwhelm them. In particular, the faint signals that FAST is designed to detect from pulsars and distant gas clouds are many times weaker than the radio noise produced by human activity. That is why building a massive dish alone was not enough. A nearly silent radio environment also had to be created around the telescope. For this reason, the area surrounding FAST was legally designated as a radio quiet zone. To establish this quiet zone, more than 9,000 residents living within a radius of 5 kilometers from the telescope were relocated. In addition, the construction of new broadcasting stations, the use of high-powered wireless equipment, and the generation of uncontrolled radio signals within the designated area were completely prohibited. The mission of FAST is not simply to receive distant radio signals from the universe. Its purpose is to analyze those signals and reveal the universe's hidden structure. One of its primary scientific targets is the pulsar. A pulsar is a rapidly rotating neutron star with an extremely powerful magnetic field that emits regular radio pulses with remarkable precision. By discovering new pulsars, scientists gain deeper insight into the death of stars, the properties of ultra-dense matter, and the nature of extreme gravity. FAST is also capable of detecting neutral hydrogen at a wavelength of 21 centimeters. This allows astronomers to determine the distribution of gas both inside and outside galaxies. It is from this neutral hydrogen that new stars are eventually formed. That is why FAST is far more than just a telescope. It is a vital scientific instrument for mapping the universe and understanding the evolution of galaxies. Although the world's largest radio telescope built by China can detect extremely faint radio signals, its single-dish design also comes with certain limitations. Because FAST's main dish cannot rotate or tilt, it cannot observe the entire sky. Despite its enormous size, it also has limitations when it comes to producing extremely high-resolution images and precisely locating short-lived radio signals. Even so, FAST remains an extraordinary instrument for astronomical research. Through this unique infrastructure, China continues to make significant contributions to long-term sky surveys. To overcome these limitations, China began construction of the FAST Core Array Expansion Project in 2024. According to the plan, the new system is expected to become operational by 2027. It will add 24 movable 40-meter antennas within 5 kilometers of the main dish. When these antennas operate together, they are expected to achieve a resolution of approximately 4.3 arcseconds at a frequency of 1.4 gigahertz. As a result, scientists will be able to identify the origins of many more short-lived cosmic events with far greater precision in the future. China's giant radio telescope would never have been possible if humanity had not first learned to understand sound waves. For thousands of years, people could hear sound, but they had never seen it. How could this invisible force traveling through the air actually work? That remained one of science's greatest questions. Gradually, scientists discovered that sound is actually a form of vibration. Those vibrations travel through the air and strike our eardrums. For the first time, humanity realized that sound was not magic. It had a scientific explanation. As our understanding of sound grew, another question emerged. If sound could be understood, could it also be captured? The search for that answer eventually led to the invention of modern sound recorders, mobile phones, ultrasonography, sonar, and even technologies such as radio telescopes used to explore the universe. And that's the incredible story behind the world's largest radio telescope. From a remote mountain valley in China to one of the most advanced scientific instruments ever built, FAST proves that humanity's greatest discoveries often begin with the boldest ideas. As we continue exploring the universe, this giant telescope may help answer some of the biggest questions we've ever asked, and perhaps reveal mysteries we haven't even imagined yet. If you enjoyed this documentary, don't forget to like, subscribe, and turn on the notification bell so you never miss our next journey into science, history, and the unknown. Thanks for watching. I'll see you in the next documentary.